We know for intelligence and insight, we need data. Data is basically bloodstream of intelligence and insight. We are going to look at some of the aspects of data and what do we mean by data preparation and some of the steps involved in data preparation for data science or AI projects. Data comes in many structures. They can be broadly classified into three. The first one is called structured, and then we have semi-structured, and we also have unstructured. Structured data include things like relational database. The data we keep in a relational database is an example for structured data. This is because the data we have in a relational database have well-defined schema. The data is in a table, and within table we have rows and columns, and we have strict data type for each of those columns, and we may have constraints for the data we have within those columns, and we also have relationship between the tables we have within the database. So because of all these things, the data is well organized and structured, so we call those type of data as a structured data. And we also have semi-structured data, and example for semi-structured data include things like JSON, XML and CSV. Here we have some sort of structure, but it is not as rigorous as the one that we have in the relational database. So that is why these are called semi-structured. And finally, we have unstructured data. Unstructured data include things like videos, images, and any free text file. They may not have any structure. So those kind of data are called unstructured data. Another aspect of the data is whether it is a static or dynamic data. Static data are data that are not going to change. Once you have collected them, it is going to stay as they were. It is not going to change. So that type of data is static data. On the other hand, we have dynamic data. Dynamic data will continuously change. This include things like, sensor reading coming from some sensor. So this can be generalized into some sort of streaming data. If we have stream of data coming continuously, then that can be an example for dynamic data. And one thing that we need to keep in mind is any data that we have may have quality issues. Okay, we can't just use them for any analytical tasks. We need to clean up the data. And some of the activities we perform as part of data preparation will be to deal with this quality issues. Okay. Now, let's understand some of the common terminology with respect to data. The first one is data set. Data set is basically entire collection of data used for training or analysis purpose. So in this example, I have taken this tabular format data. So if you see here, the entire collection of data, we have many rows and many columns. All of these that we have taken for our training or analysis is called a data set. Then we have record. Record is nothing but individual rows within this particular data set is called record. Okay, it is basically a single instance. The next one is called feature. Feature is nothing but the columns we have in our data set. So now let's clarify all of these things with an example. Okay, let's imagine that this data set is a data set for the house price. So the data set have many records, and each of the records will represent one particular house. And within each record, we'll have multiple features about the house that include things like number of bedrooms, location, and the size of the house, and so on. And those individual properties about the house is called a feature. Okay. Then we have dimension. Dimension is nothing but number of features available in our data set. So if we have 10 features, then the dimension of the data set is 10. So it is basically the number of columns we have in our data set. And we have something called label. Label is optional. It may not be available in all the data set. If the data set is a labeled data set, then we'll have it. If it is unlabeled data set, then we won't have it. Label is nothing but the target value that we want to predict. If we take the house price data set, the price of the house might be the label because that is what we are trying to predict with all these features about the house. Okay. Now that is out of the way, let's move on to data preparation. Data preparation is done for two different reasons. The first one is to change the data's format and shape, and the second one is to deal with quality issues within the data. Okay, So when it comes to changing the format and shape, it includes activities like creating a new feature, removing existing features, and formatting a data to the format that is suitable for the task at hand. For example, the dataset might have inconsistent date format, and we might think it will be useful to format them into a consistent format. And those kind of activities will also be considered as data preparation activities. Okay. And the second one is addressing the quality issues. This includes dealing with missing data, repetition, because the data set might have repeated rows, and also dealing with inaccuracies, also known as noise. So the data set might have some inaccurate values, and we need to understand how we are going to deal with them, and we need to do some appropriate cleanup to make sure the data is suitable for the task at hand. Okay. Now, I want to talk about something called data wrangling, because this is one of the terminology that you might come across very often in the data science and machine learning field. So I want to clarify what it means. Okay. So data wrangling is nothing but making data suitable for the task at hand. Okay. So it includes bit of haggling, hacking, and tweaking of shape and format. Basically, data wrangling means do whatever you need to do to make the data suitable for a task at hand. This could be, extracting some intelligence, or it could be for training a model, and so on. It could be for anything. So basically, you need to, massage the data or wrangle with the data to make it suitable for task at hand. That is what data wrangling means. Okay, now that is out of the way. Next, we are going to look at some of the common techniques used as part of data preparation. And it is not a comprehensive or exhaustive list. These are some of the common techniques and tasks performed during data preparation. Okay. So let's first move on to sampling. Sampling means taking subset of the entire data set for our task. The data set might have lot of data. We don't want to use all of them. We want to select only subset of it. And that process is called sampling. There is one important technique within sampling called stratification. When we apply stratification during sampling, then we call that as stratified sampling. Stratified sampling helps us to get the sample of the data without compromising the underlying probability distribution. Okay. Let's understand what this means by an example. Let's imagine that we have a data set which has 200 records, and 50 of those records belongs to dog image and 150 belongs to cat image. This means we have 25% dog image data and 75% cat image data, and we want to take 10% sample of this particular data set, which means we will end up with 20 records. If we do random sampling, then there is no guarantee that the output will also have 25% dog image and 75% cat image. Okay, because it is going to be random, we cannot guarantee this underlying distribution. But when we do stratified sampling, we will make sure the sampled data will also maintain the underlying distribution. So in this example, if you see, we have taken 10% stratified sampling. So we have 5 dog and 15 cat. This is still 25% dog and 75% cat. So this type of sampling is called stratified sampling, and in many machine learning and data science tasks, this type of sampling is preferred over random sampling. This is because it is important to maintain the underlying distribution of the data set, because that may represent the real population. Okay. Next, let's look at something called feature extraction. So feature extraction is also known as transformation. This is basically a task of creating a new feature by combining existing features. This will be useful in some cases. Let's understand this with an example. Let's imagine that we have a data set, and that data set has two features called mass and volume. And for the task at hand, we believe having density will be useful, and it will help model to understand the pattern much more easily, and the training process will be better. Okay, that is what we believe. So what we do is we create this new feature called density from mass and volume. Okay, so this type of activity is called feature extraction. And this is one of the common activities that you may need to perform as part of data preparation. Next one is called dimensionality reduction. Remember that the number of features that we have in our data set is called a dimension. Okay, here we are talking about reducing the number of features, because the more features that we have, the more time and effort needed for model training. The reduced number of features will help us to speed up the model training. So this is why dimensionality reduction is one of the important concepts in data science and machine learning. Some of the examples for dimensionality reduction includes things like correlation and synonymous, but there are many techniques available for dimensionality reduction. We are just going to focus on two common and simple examples. The first one is called correlation. Correlation is where we believe multiple features are related to each other somehow. For example, if we have a data set of a person, then there may be correlation between their education level and their income. So in that case, depending on the task at hand, we may be able to remove one of the feature. Okay, so that type of feature reduction is called correlation based dimensionality reduction. And on the other hand, we have another concept called synonymous feature. So we may have a person data set with a date of birth as well as their age. In that case, both of them are same data but in a different format. So this type of data set can benefit from removing one of those columns. Okay. And again, dimensionality reduction is a very big topic. I just scratched the surface of it with this very basic example. And the next one is dealing with missing-ness. This is by far one of the very common tasks that need to be performed by data scientist or machine learning engineer, because the records within the data set we have will not have all of the features. Some of the features will be missing. So we need to know how to deal with those missing features. So there are multiple ways to deal with them. Here are a couple of examples. The first one is dropping that record. If it has a missing feature and that feature is important enough, we could just drop the whole record. There are some advantages and disadvantages with this technique, but this is always one of the options. And the second option is imputing that value. So if a feature is missing in some of the records, we'll be able to guess what would be the right value for those missing features from other records we have. So this could involve very simple averaging process or taking the mode value and so on. So this type of activity is called imputation. Basically, we are imputing data which is missing. The next and final technique that we are going to look at is converting continuous value to discrete value. So this will be useful in many scenarios. This is basically like a transformation, but what we are doing here is we are taking continuous value and we are actually converting them into discrete value by putting them into appropriate buckets. Here is an example for that. Here we have continuous number. So this is basically a real value. So we have numbers like 1, 1.2 and so on. So this is a real number. And as part of discretization, we are converting this real number into integer. Okay. So this type of activity is called discretization. Basically, we are converting these real number into discrete set of integer numbers. Okay, because we could have many values between 1 and 2, and if we use all of them in our data set, it might be too hard for the model to understand the pattern. But if we convert these real number into integers like this, then it might be slightly easier for the model training. So this type of activity is called discretization. And another example of discretization is called binarization. Binarization is very similar to discretization, but here we are only mapping the input values to either 0 or 1. In this particular example, I have mapped anything below 5 to 0 and anything 5 or above to 1. So this type of activity is very useful in some data sets and for some of the tasks. Okay. Like I said, I only scratched the surface of data preparation and I only covered very basic and common tasks that we perform as part of data preparation. Okay. That is all I wanted to cover in this video. I hope this is useful. Thank you.